All right, here for week 5, online chemistry. This week we're going to look up at chapter 10, which is chemical quantities, basically focus on the mole. As you can see from this slide that we're looking at, yes, you need a calculator. Almost everything in this chapter deals with math. A lot of conversions. If you're good at the conversions we did in chapter 2, you're going to find this chapter a little bit easier because it's all about converting from quantities like number of particles, mass, volumes, and then being able to switch them in between the mole. And in fact, you can go from mass to mole, mole to volume, so you end up going mass to volume. But a lot of math in this chapter, so make sure you get a calculator handy. When we're measuring things, like I just talked about a second ago, we're going to measure things like mass, volume. When you count pieces, a lot of times what we use in chemistry is going to be the idea of the mole. It's the SI unit for counting things. The SI unit for mass is kilograms. For volume, it's the liter. And then we look at, moles, it's going to be how we count things. So first of all, if we look at what a mole is, a lot of you talk about the number that I have up on my wall is 6.02 times 10 to the 23rd and what it means. It's that important of a number in chemistry because it allows us to go the number of atoms into a quantitative substance that we would be able to hold. An atom is too small. A molecule is too small for us to, for the most part, comprehend. But when you have enough of them, it builds up into an area where you have a mass, like a gram or 5 grams. 2.3 grams. It's an actual quantitative amount. And that's what allows us and why the mole is so important. That 6.02 times 10 to the 23rd, again, it's just a number. It doesn't have a unit on it. It's just a number. It's called Avogadro's number. And basically, it's similar to saying words like a pair, where a pair is 2, a dozen means 12. When you say a mole, it's a number. And that's what it stands for. There's a couple other ones listed there. So there's 3 things we're going to basically look at dealing with the mole. It's, with the representative particles, as we call it, because it depends on what one of the types of bonds we're looking at. If it's a covalent bond and it ends up being a molecule, okay, then you would say the number of molecules equaling a mole. You notice we didn't talk about individual molecules with ionic compounds. It was called a formula unit. It was always the simplest whole number ratio. But we could have that ratio of formula units equaling the number of moles, which, remember, ionic compounds are made up of positive and negative ions. And then you could just have, if it's for a single element and not even something that's bonded, you could just simply say it's those number of atoms that equal a mole. So there's really 3 things, and that's the first part of what is identifying what you need to know. So easy type of questions that you probably could have done at the beginning of the year is how many oxygen atoms are in, let's say, this compound. And if you remember from last chapter, it would be called calcium carbonate. But if we look at just the oxygen atom, there's 3. That's the subscript. The second one here would be called aluminum sulfate. And you would have the 3 outside. We'd have to distribute that into the number of oxygen. So there's actually 12 oxygen in aluminum sulfate. And you could do the same thing with the number of ions. How many ions are in the following? Well, there's 1 calcium ion, and then there would be 2 chlorine ions. That's calcium chloride. There's 1 sodium ion, but if you remember, OH kind of goes together. It's one of those polyatomic ions from last chapter. That's called hydroxide. So there'd be 1 sodium ion and 1 hydroxide ion. And then this last one, aluminum sulfate, again, if we look at just the ions, there's 2 aluminum and there are 3 sulfate ions. Remember, they kind of group together, they bond together and still have a charge. So they're kind of separate on each other. Oops, sorry. There's what I just said as you go through the number of totals. Remember, this whole PowerPoint is on there too. So if we want to go say how many molecules of carbon dioxide are in 4.56 moles, we're able to just put that up as a conversion rate. Where again, a molecule is this because those are both nonmetals. That's carbon dioxide that we learned last chapter. So we would simply start with what's given, 4.56 moles, and then we would put it into the brackets that we would have. And we would say on the bottom, we would say 1 mole is equal to 6.02 times 10 to the 23rd molecules